Let's take a look at the patterns that can be observed in the derivatives of the sine function. And what we see here, a similar pattern happens to occur when you look at the derivatives of the cosine function. So let's go ahead and get started. So we're starting with the f of x is equal to sine of x. So the first derivative of the sine function is the cosine function. So f prime of x is cosine of x. Now, the second derivative is going to be the derivative of cosine. So we're taking the derivative of the cosine function, which is negative sine of x. And now for our third derivative, we're taking the derivative of the negative sine of x, which is negative of the derivative of sine of x, which is equal to, and the derivative of sine of x is cosine, so negative cosine of x. And then for our fourth derivative, we're taking the derivative of negative cosine of x. Bring that negative out front, negative derivative of cosine of x, which is equal to, now we have negative, now the derivative of cosine is negative sine of x. So we end up with a positive sine of x. So let's kind of summarize what we see here. Now, notice first of all that we see this pattern. I started with sine, then cosine, then I ended up with a sine, and then a cosine, and a sine. So the first pattern we see evolving is that as we take derivatives of the sine function, that the derivative alternates between sine and cosine. Now, another pattern to observe is that the odd derivatives involve cosine and the even derivatives involve sine, or a sine function. Now, one more pattern to notice is this alternating SIGN signs. Just to not confuse the sine function with the sign of positive or negative, I'm spelling out SIGN. So you'll notice that the second derivative has a negative SIGN, and the fourth derivative has a positive SIGN. So let's summarize a little bit here. We have f of x equal to sine of x, f prime of x equal to cosine of x, f double prime, or second derivative, equal to negative sine of x. The third derivative is equal to negative cosine of x. And then our fourth derivative is equal to positive sine of x. So we've gone through a full cycle, and notice that with this fourth derivative, I am now back to where I started from in terms of what the function actually is. So what could we say? Well, we could say that the fifth derivative would be the same as the first derivative, because the derivative of sine is cosine. The sixth derivative would be the same as the second derivative. The seventh derivative would be the same as the third derivative. And the eighth derivative would be the same as the fourth. And this pattern would just continue to repeat. So we could summarize this behavior with a kind of a piecewise defined function where our nth derivative of our function is equal to cosine of x if the index of the derivative is 1, 5, 9, and so forth. If it's equal to negative sine of x if our index is 2, 6, 10, and so forth. Equal to negative cosine of x if our index is 3, 7, 11, and so forth. And the nth derivative would be sine of x if the index of the derivative is 4, 8, 12, and so on. I hope this helps.